AWS Loft Talks.
My name is Ian Hummel. I'm the VP of the Reporting and Analytics platform at Mediamath. We've been working with AWS for a little over 2 years. So I want to kind of tell you a little bit about Mediamath, kind of tell you where we are in the space. So Mediamath, who are we? What do we do? We're a marketing technology platform. Real-time bidding has really taken off over the last few years. So I think a lot of people have some ad tech experience, but if you don't, these things called exchanges have appeared over the last couple of years, and they aggregate inventory from publishers. They allow buyers like Mediamath to actually submit bids on an impression-by-impression basis. Mediamath helps agencies and advertisers run their campaigns across many different channels, display, video, social, by leveraging machine learning. So we collect a lot of data about which products are selling. We take the different targeting parameters that an advertiser might be interested in. We sort of package all that up, deploy it to our bidding infrastructure, and connect to exchanges worldwide to run campaigns. In terms of numbers here, Mediamath looks at about 1 billion impression opportunities every single day. We are getting 1.5 to 2 million bid requests per second. All of our bidding infrastructure is, very low latency, very tuned, high performance C++ code that we deploy to data centers that we own and operate. So we have 9 data centers across the world that host, this low latency stuff. But increasingly, we are moving all of our data processing to AWS. We're about 75% of the way through the transition right now. And at the end of the day, we're collecting about 3 terabytes of data. And that all gets sent into AWS, into S3. Another constraint that we're working under here is that all this data is effectively transactional data. That means we can't lose any messages. All the beans have to get added up at the end of the day. This is how we create bills and reconcile with partners and things like that. More context, when I say reporting, when I say analytics, this is the platform, this is the reporting that we provide our users. That also is a bit of a challenge because this is the kind of web app where you've got 60, 70 people logged in over lunch, and they're trying to pull a query that goes back, a campaign that's been running for 1.5 years, and you've got to keep the whole thing snappy. So it's not only a big data challenge, it's also kind of a medium data challenge at the edge, right? So you've got to be able to process the data, aggregate it, and also funnel it down into a serving tier so you can keep a responsive UI, which is a big challenge for us. There's a lot of other problems, but when we think about it and try and summarize it all, it comes down to inertia. The data sets that we're dealing with, the data volume, it just does not lend itself to being shared or being analyzed cheaply or having things built on top of it. It's just heavy. It just kind of sits there and takes up a lot of space. It's hard to create QA environments, right? Because your Hadoop cluster costs you $2 million. You can't build a second one usually. They evolve these data, your traditional data warehousing pipeline is going to have evolved over time. So it starts off with a business analyst doing some SQL and maybe throw in some shell scripts here, and then we put that in a cron file, and before you know it, you've got 100 different things in your cron tab. Like, if you really want to scale this, you've got to break out of that mold. A lot of the problems are really just how do you get realistic production data sets into different engineering teams in a way that they can experiment on it when you have such a large data volume. There's hope, right? The cloud is enabling a lot of interesting solutions for these problems. So if we were to look at our data warehousing infrastructure, 2 years ago and say, hey, where do we want to be today? We'd want to be kind of cloud native, and to do that, we'd want to sort of change how we think about stuff a little bit. So instead of maybe locking up all of our data into a very expensive proprietary data warehousing appliance, we would want to just pick some simple object store and just keep that as our single source of truth. We would need a powerful data processing framework that's distributed because you can't fit everything on one box anymore. And at the edge, again, to power that UI, one of the things that's really become clear is that columnar databases are very, very efficient at that. We also want to do this in a cost-effective manner. We don't want to have to invest too much money up front. We want to scale our resource consumption along with our data volume, right? And the last one is kind of new. I don't know if anybody here attended reInvent last year when they announced Lambda, but if you kind of read between the lines, event-driven architecture is really becoming important when you think about planning your infrastructure at scale. And it's, I think, very relevant to the data warehousing side of things. It allows us to share these data sets much more easily with other teams. And I'm going to talk in more detail about how we're moving away from sort of this cron and shell and SQL and moving to something that's cloud native, event driven. Well, here's an overview, okay? So the data, like I said, 3 terabytes or so flowing into, it all lines up, it ends up in S3 at the end of the day. We do a bunch of staging buckets. We use EMR pretty extensively. We are built on top of Scalding, and if you don't know that, that's a Scala wrapper on top of Hadoop. We spin up EMR clusters for every single job because we leverage spot instances and tune the cluster size to the workload. So we try and get our workloads to finish within 1 hour. So we can really get jobs to run very cheaply, like $1 a day or something in some cases. All of our sort of control plane right now is in Jenkins, so we moved away from cron. We're scheduling everything in Jenkins. It's worked out very well for us. Would love to talk to you guys about that if you're interested afterwards. So we're kicking off all these EMR clusters. Most of these jobs are taking 3 terabytes of data and doing some kind of pivot, like some kind of analysis, boiling it down to a couple of million rows maybe, and landing it in another S3 database. And this is kind of where we ran into the first challenge. It's like we got this great data processing pipeline now, but how do we get it out to the last tier so that the UI can really take advantage of it? And that's where we started on this project called Transmitter Stacks. And what a transmitter stack is, that you see over on the left, is it's a CloudFormation stack that pairs a Redshift instance with an EC2 instance. And basically, the EC2 instance's only job is to keep that Redshift instance in sync with any data sets that we land into those aggregated data sets buckets. So like any fact table that we're updating in S3 is going to get automatically synced to that Redshift instance. And we use DynamoDB to kind of coordinate all this. So what that means, concretely, if you're on the QA team and you go away on vacation for a week, you can shut down your stack. You don't need it anymore. We don't need to consume those resources, and everything's fine. You can shut down your stack, and when you come back, you can restore a QA stack from a production snapshot. So it doesn't actually have to catch up again from 0. You can catch up, like maybe you lost a week's worth of data. You can restore from a snapshot. It will hit the Dynamo table. Every data set is represented as kind of a stream, and each consumer will remember its offset in the stream. So if a fact table was at 23 when QA went on vacation, when it boots back up from production, it might be a few hours behind, but it will quickly catch up. So Redshift's snapshotting ability is one of the things that really helps us here, and just the flexibility of Dynamo is also pretty good. And CloudFormation, of course, kind of glues everything together for us. For us, the challenge that we've had with our big data infrastructure really comes down to inertia, right? How do we share that data? How do we liberate it? We use some of the cloud primitives, and AWS has a pretty good slew of features there. And I think between Lambda, between the new features that are coming out with S3, with Redshift, it makes a really good foundation for data processing, for building a reporting and analytics pipeline on top of. And the event-based architecture, this is the stuff that we're really excited about, because I think it's going to really help the data warehouse kind of catch up in terms of agility and in terms of more responsive kind of reporting pipelines.
AWS Loft Talks.